Very quiet. So did I. I thought that he would contact you, but he didn't. Okay. Nice to see you.
دکتر من جای شما رو فکر کنم قصد کردم.
Yes. You asked a question yesterday that was a good question.
You know, he and I have one thing in common.
Yes.
We have the same exact professor.
What's that?
We share exact the same professor, advisor, Jerry Mendel.
Yes.
Yeah.
So, as you know, Jerry Mendel was my professor, and also he's his professor.
You know that I forgot that Jerry Mendel was your professor. I know that Jerry Mendel was his professor, but I forgot that he was
Right.
Yes. That's I don't think that too many students can experience such a thing because
Right.
yes, you are now a professor, and I'm a yeah.
So what I was last question,
Pardon me?
can we take this?
Oh no, professor. Yeah, just look to the camera, please.
Yes.
Yeah.
So I'm repeating what I said.
Yeah.
That,
I want to.
if you want to take a picture, it's too close.
No, but I'm filming.
Oh.
Yeah, for my records. Yeah.
So in every field that applies to every field, you can develop the methodology,
Yeah.
and then you can apply it. But it has to progress to a certain point before you can really apply it.
Yeah. Yes.
So level 2 CW is still in its early stages.
Yeah.
So at this point, there is a need for the development of basic methodology. And then you apply it. But let me give you some examples. Now, suppose that I say it is very unlikely that there will be a significant increase in the price of oil in the near future. The real question is, should I buy Chevron stock?
Yeah.
Well, it's very unlikely if there is significant. So you say, no, I won't buy it. Suppose I change unlikely to likely. It is very likely that there will be a significant increase in the price of oil in the near future. That's all by Chevron stock.
Yeah.
You see? So here is something that's not very simple. It's very likely that this and so forth. You change one word, your decision is affected
By
by this thing. But then you have to have understanding. Why is it? Why is it that this sort of a thing happens? How do you take a complicated sentence like it is very likely there will be significant? How do you put it into this form of constrain something? How do you put it in that form?
it is very likely that so the probability of a significant change is very likely, and we must calculate the probability according your that integral. Yeah, we have a distribution, and we can apply. Yes, and then we are assigning a linguistic probability to to that event. Yeah. Yes.
But then you have to analyze this thing. You see, in level 1 CW, everything is simple. Pressure is low, pressure is high. That's simple.
Yes.
Then it's more complicated. So, but I think that the Z-mouse will help a lot.
But acquiring the knowledge from people.
Yes. So, applications of CWW will be greatly facilitated through the use of ZMouse. So in your place, Professor Mattel, he sent me an email, he asked me about this or that about ZMouse. I think he had some misunderstanding about ZMouse.
Dr. Mendel, you mean?
Yes.
Yeah.
But then I explained some things to him. And so I think that ZMouse is going to be used very widely once it's understood. See? And it goes hand in hand with computer networks. So when you provide information, ZMouse helps people to communicate. You see?
Yes.
If I say, how happy are you living in Los Angeles, scale 0 to 1, you put an F mark. See?
Yeah.
You don't put some numbers. You see, there are many questionnaires. On the scale from 1 to 10, put down something, something. Many things of this kind.
Yes.
But then you have to choose one of these things. But here, it's visual.
Yes.
Visual, you put this. And this.
Yes.
Because in your head, it is visual. It is not number 7 or 6. It's not that way. So when you are asked to choose on the scale of 1, it's not natural. ZMouse is much more natural.
Yes, because
It's much more natural.
the most important part of the sensory motor system of human is yes.
ZMouse.
Yes, making
And
sense,
then
making sense.
Making a small thing means that you're sure. Bigger, that means not so sure. It's not, so not say that how much do you like Bangladesh? It's not a simple question. So you would not have a very precise point because it's not a simple question. So you put something in there. So ZMouse helps to capture that. But once it is there as a trapezoidal, as I said, then you use computing with words
Words, yes.
to compute the answer. So with the ZMouse, for example, this the first sentence is very unlikely this that. Suppose that you're a stockbroker and I ask you, how likely is it that there will be a significant increase in the price of oil in the future? Instead of saying very likely, unlikely, he puts it.
Okay,
here's
this is,
ZMouse.
yeah.
He said, here is my perception, you see? Here's my perception. And then if it is here, you take one action. If it is here, you take another action.
Based on that.
Yes.
I remember because I've studied some of your papers, those papers on Dempster-Shafer theory. You have another interesting example about estimating the number of nuclear missiles of North Korea. Yes. So I think that if the community is successful to develop your ideas, your first purpose of for fuzzy logic will be applying it in economic systems, social systems will be realized more than before.
See, this computing with words will help to create applications in those fields, human-centric, economics, this, that, so forth. Because at this stage, 90% of the applications are still in control, consumer products and things like
Yes.
that. Only a small number are in these other things. But I'm very pleased that you are thinking about these things and you have a good understanding of the issues.
Yes, because I always refer to your papers rather than books because I think that some of your ideas are I don't know why, but some of your ideas are well understood in the fuzzy community, but some are I think so. And I like those non-famous ideas. For example, for my master's, I was working with Dr. Pedrich. and we worked out a solution to paradoxes based on your work on the liar. Paradoxes, mathematical self-referential statements.
Large
He-
paradox.
Yes, paradox.
I
And
wrote a report on that. didn't you?
yes, I've seen your report. Yes, and you accept the fixed point of that mapping as the solution to the liar. But if the self-referential statements are multiple, are more complicated, there may be more than one fixed point. And we made use of type 2 fuzzy sets to aggregate all those, because that's a heuristic fuzzy set over 0 and 1, and the membership is 1/2. So it's a type 1. But if we have more fixed points, it's one of the chapters of my master's thesis.
There are actually quite a few papers on that. Other people have written this.
Yes.
If you use Google, you'll see those papers.
Yeah. Another work was, because I think that you are the only one, you are the only professor that used that term, heuristic. Maybe Dr. Turkson also uses that word. Others use truth values, yes. I also solved the inverse truth qualification problem for type 2 fuzzy sets. Yes, and showed that the heuristic fuzzy set is a type 2 level 2 fuzzy set.
Very good.
Yes.
Very good, actually.
Yes.
I'm very glad that you are doing those things, because there are many people who don't really understand it. They don't understand it, yes.
The papers
The
are
reason why I
stuck.
use heuristic because it rhymes with possibilistic, probabilistic, otherwise also it's a truth value. Truth value is Anglo-Saxon term.
Oh,
Yes.
yes, but that's Latin, yeah?
Verity is Latin term.
Yes.
So for people in France and Germany and this and that, it's much more natural than truth value. Truth value is Anglo-Saxon.
Yes.
So in general, I try to use terms which are sort of universal rather than just Anglo-Saxon.
Anglo-Saxon. That's the reason. That's the reason.
So you can say verity distribution,
Yes. Oh, and I was bashed. Yes, all my. Bless you. All the papers are stuck. Yes, because all the reviewers insist on application. That's why I asked you such a question. I understand that we still need to work to develop the mathematics.
In level 1, application is relatively easy. In other words, if you know nothing about fuzzy logic, and if you study it for 1 or 2 or 3 or 5 hours, these rules you can apply to something.
Yes.
Here it's not so simple. You cannot study it for 1 or 2 or 3 hours and then apply it to something. It's not so easy.
Yes, I agree. For example, in the Magnus problem, first of all, I think that I don't agree with you that most.
Don't hesitate to disagree.
Yes. I don't agree with you that most is a monotonic quantifier. I don't agree with you.
Why not?
Because when we say, for example, most of a population have an attribute, it doesn't imply that all of the population can't have that attribute. So I don't think that the compatibility of one with that most is, at least it's not one. And so I modeled it with a.
Well, you see, the point is this, that I assume that most of this sort of a thing.
Yeah.
But you say that, that it
Then
goes
like
down.
that.
There are many things like that. There are many things like that. We assume they're like that, but in fact, Something like that.
دهمین راهنمایی فنی علومی فاندیشن سال 2019